One second, one second. I need to run a timer so I know where I am, because with the questions I can get a bit carried away. Yeah, but that's my ritual. And I also need to have the water because I'm dry as a mummy. Okay, okay. I hope I just don't pour that all over my laptop. Right. Yeah. So I guess everybody's ready. If you're ready, then I'm ready. So, hi, I'm Michał Bultrowicz. I guess you could say I'm like a holistic backend developer, Python backend developer, because I write the code. Well, I can do that. I didn't do it all the time in all the places I've worked at, but I can write the tests, I can write the code, I can write the infrastructure code, the metrics, the alerts, and that gives me, I think, a cool perspective of what's needed to really build and deliver working software. So, yeah, nowadays I'm trying to veer off into like end user software, so like just apps for people. But yeah, that's not important right now. What's important right now is that I'm going to be talking about the developer workflow that you can have while working on your code, on your Python code, if you use local tests with Docker Compose. And if anybody's interested, the slides are available at this address. You're gonna find the dev workflow with local Docker Compose tests there, and there's a source code to all the slides. So all the links. There's gonna be a couple of links in the slides, so all the links are there if you wanna check it out. Right. So I would hope that if you're here, you know what Docker is, but I guess we can't bet on that. So who knows what Docker is? Okay, who's used Docker? Okay, it's not bad. So I'm gonna give intro into what's Docker. So it's a technology that enables you to have like a process or a group of processes that are separate from the host's system. It's like a namespace, literally. They have a file system that's separate from the host file system, and it's a bit like a VM, virtual machine, but not really. Oh, and if you use Docker or containers, you're actually always using Linux, because if you have Docker on Windows or Docker on Mac, unless they've changed something in the last year or so, you actually have a VM that runs Linux and has a Linux kernel, because containers are a feature that's only there in the Linux kernel. So yeah, that's a fun fact, I guess. Right, so Docker is an implementation of containers. There's a couple of them, although I've only ever used Docker, but I've heard good things about Podman. I think Red Hat is investing in that. And yeah, and Docker Compose is something that it's another tool written in Python that enables you to describe and manage a group of related containers. Right. So today, most of the examples are going to focus around this sample application. That's a link, by the way, so you can find all the code there. The application is a simple Python REST API coupled with a Postgres database. It only has 3 endpoints. One enables you to create a new node. Another enables you to retrieve a node by its ID. The third enables you to get all the nodes from your database. Right, so this is everything you need to Dockerize your app. So the details aren't that important, and I know that's quite a bit of code to just throw out there, but you can pinpoint a couple of things. So this is our Docker Compose file, and you define services here. So we have 2 services: the API, which is our Python application, and the database. Both the applications bind some ports so that we can talk to them over the network. Python is going to be bound on 8080, Postgres 5432, which is default Postgres port. Another thing, if you're using Docker Compose, you specify configuration for the applications as environment variables. So our app takes only one, which is the Postgres host, and that host is equal to database. So Compose's networking gives you this nice thing that the names of the containers become hosts on the local Docker Compose network. So API can just do HTTP post to database colon 5432, and it's talking to the other container. By the way, there's something I forgot about. If you have any questions during the presentation, just raise your hand, when you feel like it, and just shout the question at me. I'm going to repeat it into the mic, and hopefully I'll answer. So just bear that in mind. Right, where are we? Configuration. We don't need to pass any more variables here because everything else, all the other Postgres variables are just defaults because the application has some configuration defaults. Another thing of note is that our Postgres container has a volume, and that's gonna enable us to have persistence. Because if we wouldn't have a volume, if we would kill the container and it would get back up again, it won't have any data. And that's not something that you usually want your databases to do. So if we have this volume, then the data is going to be persisted across restarts. About the Docker file, not much there. Which is basic stuff, copying over the code, installing the requirements. Well, actually, this is copying over the code, and this is running a local HTTP server. It's running UVcorn because the application is using Fast API as the backend framework. And so this means this build target here is going to hook, Compose is going to eat that Docker file. Let's say if we say to GitHub, it's going to build that Docker file as well. And we don't need to build Postgres because we're just using a well-defined image. Right. You might notice I'm using Makefiles. I know that some people don't like Makefiles, but in general, what I recommend is that you have a single centralized file, like a script file, that has all your development operations, whether it's like running the application, running the tests. It should all be defined in a single file. So you don't have like disparate doc files or whatever, or people wondering how do I actually work with this application. It's all in this one file. And also Makefile has this nice property that it runs on pretty much everything. It's on the servers. I think you can run it on Windows. I know some people do. And it gives you tab completions. So you don't need to type the entire target if you want to run something. You just do make S, and if it press tab, then it would show me setup development if you have tab completions set up properly, which isn't the problem in like modern shells. So use ZSH. Yes. Right. So the question is, what's the benefit of putting the explicit shell declaration? So make is a bit of a bastard, and it's not going to give you the shell you think you're going to get. So most often, you have your bash, and everybody's pretty much used to bash, but make will use shell, which is older and it works weirder. So bash nowadays it's everywhere. So let's just I guess the lowest common denominator can be bash, and it's useful to have that explicitly. I've wasted hours or days of my life in total over weird shell issues in Makefiles. Yeah, don't let your Makefiles grow too large. They're not a good place to maintain code. Yeah, but that's why you have the shell declaration. Okay, other main commands. Setup development, which just installs all our Python development tools. I'm using Poetry there. That's gonna create a nice local virtual environment if you have like one flag set up. And then there's run, which is going to start Docker Compose and run the database migrations. And these are like sub commands with like run target has two sub targets: start compose, DB migration. They're defined here. So you see, Makefile enables you to compose commands together. And one note about migrations in this Docker setup, you will have to inject some weighting into them. It's usually simple because migrations are just Python code, but because we do start compose and then immediately try to run migrations, Postgres is going to take a few moments to get up. You might start your migrations before Postgres is actually responding, and that would just crash. So you just, whatever framework you're using, you can inject sleeps or awaiting in the migration so that they're wait and this thing works nicely. So with that, if I would give you that repo and we have somebody new on the team, and I just tell them to run those three commands, and they might have a clean environment. Okay, they need to have Python, they need to have poetry, so it's not entirely clean, but it's pretty clean. Anyway, if they run this, they have a working local application. They can play with it. They can modify the code, observe how it behaves. They can talk to the database, see the data that's getting returned through the application. So I think that's pretty sweet. I've noticed that a lot of teams neglect that ability to experiment locally, and it goes bad over time. I think if you have that ability to play with it locally, it's going to save you a lot of time in the long run, and is going to improve quality dramatically. Also, you have very simple documentation of how to run the application. It's not like install this, install that, and do all sorts of weird steps that go out of sync over time. Excuse me. Right, time to actually have some tests. I'm going to show you two examples of kinds of tests that aren't unit tests, because a lot of times when people think about testing, it's unit testing. Integrated tests aren't unit tests. They get referred to by different names. You might hear integration test. I don't feel very strong about it, but I prefer integrated because it implies that the test is integrated with something. It's not testing integration of things, because you can test integration of like 5 applications together, and that's not what an integrated test is. Integrated test checks your internal interfaces, so like a class or a function that connects to an external system. In our case, Postgres in the container. You can see a simple integrated test here. We just create an object which is a string with a bit of randomness, and that randomness comes in handy with these kinds of tests to be able to differentiate between different things in the database. Excuse me. We create an object which is just a repository pattern object. So this object is going to be responsible for talking to the database and actually storing objects, retrieving objects. Right, that's our range part of the test. The acting is just, just running a function. Create me the node with this string contents. And this will actually, from our test, from our Python test that's running outside of containers, it's just running in our standard system. That's going to call out to Postgres and do stuff, actually write something to the database. And then the test code also calls out to the database, because it can, to verify that something happened on the database. With that, we don't need mocks. Sometimes we will do, but we don't need mocks to check code that's talking to the database or talking to the queue or stuff like that. Of course, to have like a full certainty that the nodes repository object is going to work, you will need more tests. But after you add your tests for the rest of the methods, then you can be pretty certain that nodes repository works correctly. Like you have proof that it's talking to Postgres and it works. So after that, you might, in your unit tests, take nodes repository and replace it with some mocks, or replace it with an object that inherits from nodes repository, and and doesn't call the database, so that you have faster tests. The second kind of test I would like to mention are, well, I call them external tests, but it's not a name that I've found in literature. It came up in one of the companies I worked at. We were talking about functional tests or end-to-end tests of the application, but it wasn't very clear what we mean by them. So external means that the test is talking to the app from the outside. The test is external to the application. It doesn't use any internal interfaces of the code. It doesn't use, well, you can use some of the application code for like utility stuff or whatever, but you should minimize the use of your application code in your external tests. Also, it would be nice if the configuration of the app that you're running the test against is as close to production as possible, because that gives you more certainty that things are actually going to work. And with our simple Docker app, like we could just take that image and put it in production. It would behave the same if we would attach like AWS Postgres. So here we are running the production config because the application doesn't know it's not in production. It's just running in a container. Right. One warning about them though, they are harder to debug because it's not like you can just drop in a debugger. With some tools you can, but by default, your tests are a completely separate process from the application there. You're not going to get a stack trace. You might get error logs in the container, which you will have to read during a test like that, but you won't just get a nice stack trace. Right. But let's get into the meat of the test though. You might notice that they look a bit like user acceptance tests, if you know what that is, because you can only use the interfaces that the application is explicitly enabling to the outside world. So, for example, if I store a node, I could believe the application that it did store it, but it's better to test the application that it actually did store it. And how do I test that the application really stored it? I ask the application again, give me that node that you gave me before. And that bit of randomness helps us prevent any false positives, because I could just write the implementation that would return string AAA, and if my test would just, file node AAA, then, we could get a false positive, but, those bits of randomness prevent any false positives. So what happens here? This test actually calls out to the application in the container, gets the result, then tries it again, give me that node that I just saved. Okay, that's fine. And just to be a bit more interesting, we also get all the nodes and look through the entire collection that we've received and see that our node is actually there. What you might notice here is that, a lot of times when you're testing and you're testing for like, returning some collection, in unit tests, you should always know what the collection is going to be. Here, you can't know what the collection is going to be because the system is sort of live. It's like a small local deployment. So, the tests can't know what other tests ran before and put stuff in the database. So that's something to be mindful about when you're structuring your tests. Some code that's missing from the previous slide. That's a bit of PyTest trickery, because you see that test use an app URL parameter. It's actually a PyTest fixture, which is session scope. What does that fixture do? Well, it actually just returns the string That's the address of the local application. But before it returns, it waits for the application to get up. It uses Tenacity to basically do retries. So we just try to ping the local container until it successfully returns from a basic HTTP call. If it doesn't return in time, we're gonna raise an error and we know we have some failure and we need to investigate container logs probably. Yeah, and one other thing to note here is that we're using session scope. That's gonna ensure that this thing is only going to run once per the entire test suite. So, we don't need to wait every test, for example. Right, running the test requires, well, it doesn't really require, but we might add some more stuff to the Makefile for it. I recommend having a single command that does all of your validation. So all of the static checks, running the tests, it's all just one command. You do make check and you know that the thing should be working. Of course, you can compose those commands. So we have static checks that does a couple of different things. Each of that is a separate command. Sorry.
Could we get back to the previous slide?
Yep.
Two questions actually. What does this monkey sign mean? I don't remember.
You mean this? Right. So the question is, what does that mean? Excuse me. That just means that make won't echo the command, because by default make echoes all of the commands. If you put that on the first character of the line, it's going to skip the echo because I'm making the echoes explicit. And putting dashes is useful if you have like a bunch of commands that just run in sequence and you want to visually distinguish where the output from one command ends and another begins. So that's just like a useful little aesthetic tool. Right. With those two kinds of tests, we get something that we would never get from a unit test. Like, no matter how many unit tests we'll write, we'll never know if the app actually turns on. And I actually had a lot of issues like that years ago, that we had like high test coverage, but we would deploy the application, luckily to the development environment, and it would just crash because somebody messed up something about the config, something about container definition, something like that. But here, we have concrete proof that the container is building and it's working because it's actually, returning responses for our requests. The calls actually go through all the layers of the application and return to us. So yeah, that gives us higher confidence. We can never be sure that the application is working in the general case, but we can be more confident that it's working, and that's a lot. And you might notice that, I haven't used any mocks here. It's quite fast to write these kinds of tests without mocks. And they also help you get high coverage and all that stuff. Right, but another cool thing that they give us over unit test is the freedom to use the tools that we want. Because oftentimes, when you write unit tests, for example, with Django or like some other standard web framework, like we don't actually talk to the database, and we can only use the features of the database that the framework supports, which is often very limiting, because there are things you can do at the data layer that's gonna cut down development time by a lot. It's gonna usually, you can do tricks in the data layer, for example, in the database, that are going to be way faster, more efficient, and faster, more efficient, and just sometimes aren't available in your backend code. Like, there are things, there are certain certain properties that you can only get in the data layer, for example, and never in the application that's talking to the database. So if you can actually test anything about the database. Like you can test database triggers. You know, you don't need to write as much Python code. You can write more SQL, but you can have very tested SQL, which is nice. They're generally they're slower than unit tests, you know, integrated and external tests. But if your app is fast, then they will be pretty fast. But sometimes they pull the rug from under people because there's no test isolation. Usually, like, you know, traditional knowledge says that all your tests should be isolated. We don't get that here. So we have a bit of chaos. Like if you want to reset the database every test, let's say, with something like Redis, I actually done it and it's possible, but you basically that stops you from using any test parallelization, because, you know, if a bunch of tests run independently and they're like cleaning the data and using the data, you know, that's not going to work. And if you try that, you know, cleaning with SQL, that might be a bit slow. So yeah, we don't reset the data; it just lives. And some tests, like getting all the nodes, will have to accommodate that fact that, you know, we don't have isolation, where we can have like random junk there, and also like that local database and, you know, local app just running there and the data gathering over time, that might give you like weird issues. But with that bit of chaos comes more realism. Like if you deploy a web application in reality, like if you have like a web store or something, it's not going to be resetting its data every second call. Like that never happens. So tests should work on a model of reality, of the real application, and having that bit of chaos is more real. A lot of times, you know, I was bugged by some like weird thing happening to my app after I do this change locally, only to, you know, like spend 3 hours on that, and shit, I'm like late on delivery on that feature, but hey, I've actually found the bug before it went into production. Because usually, you know, it could go into dev and then be caught there, but dev is quite sterile a lot of time as well. I also like to have messy devs, by the way. So yeah, having that messiness locally enables you to find the bugs quickly. Also, if you have like integrated tests that are a bit more asynchronous, and these are fun, like write something to the queue, wait for the queue to get back and whatever, and those tests are flaky for some reason. Like sometimes they pass, sometimes they fail. A lot of times when I had issues like that, I actually found bugs. So, you know, if your tests find bugs, they are good tests. Right, so you fix more bugs, you increase the quality. But if you have problems with like the local database and you just don't have the time to deal with it, then just do docker compose down -v, and that's gonna wipe the volumes as well. So you're gonna start with clean data. How do I separate the tests? I just have my test folder, which explicitly says these are external, internal, and unit tests. It's good to be mindful about what test is what, because you have different expectations about them, and you shouldn't just start doing everything as an external test, because, you know, they have upsides, but they're also like harder to debug. They are slower. So, you know, just be mindful. You know, they're a good tool, but don't overuse it. But one cool thing, if you have that separation with PyTest or pretty much whatever testing tool, you can, you know, run subsets easily. Just, you know, PyTest unit, and I run only unit tests. And if you want to know more stuff about what I think about these tests, there's an article here underneath that link. Right. So nobody has any questions so far? Okay. So yeah, our application is very dumb and simple, but I can tell you that, you know, I've did variations of those techniques in 3 companies, and there seems to be no fundamental problem with them. Like, they were working. Usually my apps were of the like higher end in terms of quality and reliability. So it seems to be fine. Like whatever whatever tool has a Docker image, like you can integrate it with your app, and it's actually a part of your application. So you can write less code and rely on like services and databases and just tools more. Couple tips: if you're using something like AWS and you're relying on like S3 or whatever, there's a tool that you can run as a container that's called local stack, and it just mimics, it fakes AWS services. There are some like simulators for Google Cloud and Azure, but I don't think they're as featureful. Also, if you want to fake out an entire other application as part of your test suite, if it's a REST API, there's this tool called Mountebank, which you can configure with HTTP to respond with HTTP. So it's like a faker of REST APIs, and I actually have a library to manage that in Python. By the way, the docs are very outdated. Use external Mountebank class if you ever get to using it. Right. Another very cool tool that I don't see people use enough is the ability to reload your code quickly, because normally if you want to put code in the container, you need to build the image, you need to run the image again, but there's a shortcut that you can take to just have the up-to-date code hooked, like mounted in the container all the time. I usually set that up in another file, Docker Compose override YML. That's automatically getting merged with your basic Docker Compose file. What I said there is, I add a volume for our API container that just mounts my local directory with the code package to the place that that package is located in the image, in the container. So if you have that, your applications your container is always going to run with the most up-to-date code. But you still need to, like, if you change the file, you still need to restart the container to make the changes take effect. So you could, right. So we need something that's going to reload the container on code changes. Like, that's pretty sweet that you just save the file and the container changes. You could do that with some like framework tools. Pretty much all the backend frameworks have some tool to just watch the code and reload the application when it changes. But there's also a universal tool called Enter. You basically just pipe a list of files into Enter, because FD is like a better find. So this finds all the Python files in my application's code and pipes that to Enter. Then Enter is going to start watching those files for changes, and it will tell Make to restart the container when that happens. So you can marry that with tests that run on file changes. So you just add the code and you have the tests running, and you don't need to like click anything to run the test. You just have feedback, constant feedback. And to have that working, I've actually added that application wait is just so this is going to work. Because if you would save the file with the code, Enter would reload it, the tests would run, but the tests would run before the application managed to get up. So that's why we have that waiting for the application in the tests. So, FD and Enter, very cool tools. Righty, that's it for local development. Now let's get on to the CI, which is the server that, you should have code validation that happens independently of anyone's personal laptop, just to make sure that there's no weird thing happening. And I would advise you to remove that Docker Compose override file when you start a CI run. Why is that? Because theoretically, you could build Docker images without any code, and the volume would just make it work magically, because you only run it locally with the mount, you wouldn't notice that you're missing your code. So that's why I like to keep the override files minimal, and I just delete them in the CI run at the beginning. CI should use the same makefile that the developers use, or your script file if you don't use Makefile. Although I wouldn't use makecheck, because this is just going to give you like a wall of output, and also on the first error it's going to fail, and you might want like more information about what succeeded, what failed. So most modern CI/CD tools enable you to define steps, and you can have a bunch of parallel steps that run your tests, all of the static checks separately, and then you see individually which ones failed and which ones didn't. In the case of an application like that, if you run your tests, the tests are going to build an image, a Docker image. You should, if the tests pass, you should tag that image, push that into a repo, like your company's Docker image repository, and use that in deployment. Don't rebuild images on every deployment, for example. That might lead to bad outcomes, because you might think you have fully repeatable builds, but sometimes you don't. Or sometimes somebody pushes like a image to Docker Hub and they use the same version even though it's a different thing. So just build your images once and just keep them. Right. One more caveat: if you're using something like self-hosted GitLab CI with like a simple runner that just runs a sub-process for every test run, you might need to think about free ports. Earlier, I hard-coded the ports, so like the API is always running on 8080. If you have that kind of a CI setup, like that simple self-hosted GitLab CI setup, and two developers would push two feature branches at the same time, they would both run the same Docker Compose, you would get, like two separate asks for the same 8080 port and two separate asks for the same 5432 port, which, one of them is going to fail. So you don't want that. There's this simple mechanism in Docker Compose that enables you to have default values, but take stuff from the environment variables if they're present. So here, if I would change Docker Compose to look like that, our local tests don't need to do anything else because they're still using the default 8080. But if we want to, the CI can inject that port. By the way, this is the best way that I found on the internet on Linux to find a free port. Something from Stack Exchange. It's actually a small Python script. And that's how you would use it, to just get free ports and get going. Right. There were more things on the agenda, but yeah, I didn't manage to prepare them, and I'm almost at the 40-minute mark. So yeah, debugging code in containers, you can attach to the Docker image and just run like simple Python PDB debugger, like command line debugger. You can do that. But there are also tools like, if you use something like PyCharm, you can have remote Python interpreters in Docker Compose, and you can use that to hook into the application that's running in your Docker Compose, and you can have like your normal IDE debugging with breakpoints and stuff. Yeah, about changes to production code for improved testability, I think it's okay to change your production code so that's more testable. If you have something tricky to test and the code isn't just yielding to testing, maybe add like another endpoint that's going to help with testing. I think that's fine in certain contexts, so it's not haram or anything. Right. That's it, I guess, unless you have any questions. Okay, so the question is, what do you think about running external tests against the development environment? And I think that's actually like that's very good. With a test set up like that, I didn't really get to that, but you can use the same test and just, configure the endpoints and just run them against a against a deployed environment, because they treat the application like a black box. Give me the database, give me the application. You can just point them at any deployment and run those tests. And yes, I think that that should be done. I also think that testing in production should be part of your monitoring. So you could take tests like that, have like a test organization or test users, whatever. If you need credit cards to set that up, do that. You're gonna save more money than if you have bugs. But yeah, that's something that's the way to go. Yes.
Yep. That one. Okay. So first of all, thanks for the talk. I learned a bit or two. My question is, do you know any modern guide to Makefile? Because it's intimidating, to be honest.
Yes.
Yeah.
I don't know. Like, don't use a lot of it. Just have build one Makefile once and don't build any logic into it. If you need more logic, have scripts and run scripts. I did run like more elaborate Makefile functions, and they were horrible. So just use it to aggregate all the knowledge and have like entry points and composition of commands, I would say.
There was one question from the stream. I mean, more like comment. Since V2, Docker Compose is written completely in Golang and integrated in the
Okay,
Docker.
so apparently I lived under the rock too much and didn't notice that. Like, really, they rewrote that?
Yes, it's now implemented into the Docker itself. Like you put Docker Compose without a hyphen but a space. Like it's inside the Docker itself.
Yeah, didn't know that. It's fun.
Hi. I have one question regarding the Makefile.
Yep.
Is there any specific reason you didn't want to run those Alembic migrations inside of a container?
That I didn't want to run migrations when?
Database migrations inside of a container?
You can do that. I did do that at one point. Like all of your tests and your migrations could live in a container. You could also just stick it all in your main application image. It's going to grow a bit, but Python images are usually big anyway. So yeah, there's the only reason why I keep them outside of the container is just it's easier to debug. I just I have my local virtual env. It's faster to run. That's the only reason. And if you have like an entire team of Python people, then they usually have Python tools. When we had a team where people weren't expected to know Python, but were expected to run those things, then yeah, I would put the migrations and the tests in a container. Ideally, it would be a separate image that uses the base image. But if you're short on time, just stick it all in one image. You're gonna save what, a couple of megs.
Thanks.
Questions? All right, 3, 2, 1. Thank you for your presentation.